We discover RCC tank stand design secret using Tekla Structural Designer, and the dimension of this tank stand is 6 meters as the height. We have 2.4 meters as the length, and over here I have 1.4 meters as the width successfully. And this is going to be carrying water capacity 10,000 liters, which I have been able to carry out some load calculations, and I came up with a total pressure of 43.213 kilopascal or kilonewton per square meters. So I will be taking this load to be approximately 44 kilopascal. That is what we are going to be using to design the reinforced concrete tank stand structural elements successfully in this video. So you are very welcome to this video. Stay throughout this video to gain the whole knowledge in this video. And do not forget to like and subscribe to our channel. Let us get started now. We navigate to the file menu and we click on the new to create a new project, and then I will click on yes to save this particular project. Now we are in a new project in Tekla Structural Designer. The first thing you do is for you to set your code of practice. Go over to the setting, click right there. In the setting window, make sure the right country code is selected successfully. If you did not see a country code right here, click on the import right here and import into your country code so you can see other countries right here. So after you import in your country, click on active to make it active, just like this. Then we proceed. For the sake of this video, we are going to be considering UK settings, which is an Euro code. If you come to the codes, design code right here, you can see the region. United Kingdom Euro code is what we are going to be considering for this design. Click on the OK options. Now we go over here under the ST base. We navigate to the modeling tab right here. Then we want to create levels for the tank stand. You know, the tank stand has 2 levels, total of 6 meters. Click on the construction level right here in the level panel. So here in the construction level window, we need to click on the insert above to insert the first level, insert the second level. So over here we have the levels to be 3 meters, so key in 3 right here and 3 right here. We have total height to be 6 meters right there. So at the level 1, the type is going to be structural slab level. At level 2, the type is going to be structural slab level as well. And then the base level is going to be TOF, which is the top of foundation. And each of these levels are going to be unique, as you can see from the source right here. Then for the slab thickness, we have it to be 180 millimeters. Slab thickness for both levels 1 and 2, you can see. So this is the structural level for the reinforced concrete tank stand, that is withstanding a water capacity of 10,000 liters successfully. Click on the OK options. You know, one thing you have to understand in engineering design, we assume and then we check if our assumption is correct. So using 180 as the thickness of the slab for this tank capacity simply means I'm just trying it to see, but based on experience, I know 180 millimeters slab thickness will be enough based on my experience, and we will check and see if it is enough or not in the course of this presentation. Now click on the OK option. We are done with the structural level. If you come to this tab right here and expand the level, you can see the 2 levels we created, the base, the 1 and the 2 levels successfully. So now we want to start to create grid lines. So we need to navigate to the base level, double click right here and select make it active right here. You come to the modeling tab and then over here the grid panel, click in this drop down menu and select rectangular wizard. That's what we'll be using. So over here, you can make changes to your grid name, you can make changes to your color and the rest of that. And then the grid, you can be able to check which of the level you want to populate it in this provision. So we are populating all throughout the levels. Click on next options, and then you want this grid line to start from the origin 0 meters x and y. Next options, and then for the all lines style we have this dot, dash dot, so you can't be able to change it through this provision, but we go by the default. Click on the next option. Okay, here we go. X direction extent, we have here to be 1, and then here we have it to be, we have here to be, let's say 1.4 as the width of the tank, 1.4, and then we go next. This provision for the y direction extent, we have it to be 1 count, and then here 2.4 right here. Okay, so but we really want it to take this shape, so what we do is we get back to previous right here, and then we change here to 2.4. all right, then get to next. Here it's going to be 1.4. All right, so this is the grid line set out. Click on next, and then finished. So we have done with the grid line set out for the stand. What we just need to do next is the reinforced concrete columns. So we come to the reinforced concrete column, choose these first options, and then the top constraint and the bottom constraint is correct. You have ST2, we have ST base right there. For the characteristics columns, we have the material types right here as concrete, and then it is fabricated as cast in place successfully. Scroll down, you scroll down to the concrete class over here. We will choose to use 25 concrete class. For the column sections right there, select in use provisions, and then we use the minimum column sections. Minimum column sections is 225 by 225. This is the minimum column sections. All right, so we try these sections and see if it will be able to carry a water capacity of 10,000 liters. All right, so click on the OK options. We scroll down right here, and then every other things, I think we leave them positive for now. Okay, for the nominal cover is 35. That is okay. All right, I just do a window over the grid line intersection, release my hand, and I have my column being placed successfully, just like this, but they are not aligned. So what you do, you select this, and then you come over to where you have an alignment. Once you scroll down from here, you see an alignment right here. Here is left, take it to center. Okay, which is the minor snap level, and then the major snap level, you have to change it to center as well to centralize the reinforced concrete column successfully. The same thing applicable to this one. Select it just like this, come to the alignment provisions, change here as well to center, and then change this provision from right to center as well to correct that. If you go to 3D right here, you see what we get. So these are the reinforced concrete columns connecting the ST base, which is the top of foundations, and the topmost level, which is ST2 successfully. So now we navigate to the ST1. We need to model beams at this ST1, which is at 3 meters successfully. Click right here in this provision, pick on the beams, and then you check the beam sections actually. So we are going by this concrete class for the beam as well, and then for the beam section we need to change this beam section from these provisions. We have 225 as the beam sections, and then for the depth we have 450 successfully, and it's going to be a rectangular beams as you can see from here. Click in these provisions, and then you do a window over the grid line intersections just like this. Release your hand to have the beams placed. Okay, we navigate to the ST2. We need a beam right there at the ST2, but at this ST2 we actually need some cantilever beams. Okay, so the cantilever beams are going to be like 450 away from the grid line 2, from the grid line 1, grid line A, and as well as grid line B successfully. Okay, so we click to save this model first with a name. So once you click on the save provision right here, a dialog will pop up. So for us to save this project as a tank stand, so we just type here as a tank. We type tank stand right here, tank stand. the design. All right, so click on save right there. So we have successfully saved this project. Now we want to be creating a construction line to actually give us those cantilevers provisions that we need to apply it. But before then, we can first of all decide to create our beams. Okay, but I just want us to create that. So if you want to create the additional grid lines in Tekla Designer, come to these provisions and click here, and then you can come to these parallel provisions, pick that options. Now select the grid line you want to actually offset, then move your hand upward, use F2 on the keyboard, click on the, just press F2 on the keyboard. So we need 0 point, type in the length that you need, 0.45, just like this, and hit on the enter on the keyboard. All right, so that extent is being marked successfully. So you will now start to pick the first point, and then you pick the second point of the line, just like this, to have it placed. You can see. So you escape, and then you have to do the same thing. Pick on that parallel line, select on the green line, move it this way, press F2 on the keyboard again, and then key in. Sorry, you need to use the tab key this time around, just like this, you see. And then you can see the info box right there. Now type 0.45. all right, and then enter. So you can see the marked point. So take your hand to where you want to start that construction line, picked it, move your hand to where you want to end the construction line, and picked it, just like this. It is being placed. That is it in the direction of grid line 1 and grid line 2. You escape. We want to start from the direction of grid line A and B. So A first, you can see F2 on the keyboard, 0.45. Enter. All right, so now you move your hand to where you wish to start this grid line. I want to start it elsewhere. Pick that point where you want to end it. Elsewhere right here, just picked here successfully. Okay, I escape. I picked from these directions, move my hand this way to the right, F2 on the keyboard, 0.45, and then enter. Move your hand elsewhere right here, picked, come over to this side and picked successfully. All right, escape. Now we have, set out our cantilever beams grid line successfully. So you want to start to place the beams. As first, you click in this provision, pick on the beams. You can check the properties of the beams right here. Everything is good right here. So what we need to do now, just do a grid line intersections from here to actually place the internal beams. All right, so for the cantilever beam, you have to be careful in placing it, otherwise you will not be able to apply the cantilever function properly. So watch me do it and watch me closely. All right, so my first point is this point. You have to know your first point, where you click first, because that is what we use to apply the cantilever. I click there first, and this is my second point. The second point is actually the cantilever. All right, the first point is supported, so that is what I do. After which you can double click to have it placed, and then you escape from the keyboard. You pick the first point, double click. So all the beams, your second point is going to be where you have the cantilever. Take note. All right, so first point, second point. So at second point, you have to double click, please, to have the beam placed just like this. First point, second point, first point, second point. We are good. Now we click on save option to save this model, and then you can validate this model. Now let's see what is going to happen. Validate this model. Yeah, you can see we are having a validation warning. Navigate to 3D. So this is what we get as our beams at this level. All right, you see. So now validation warning. What is the warning? Select on this. Select on this. Expand the model. We have general load cases. That one is not a problem. Over here we have member may not be supported. That is the cantilever we just placed, because we have not made this a cantilever. That is why you see that these beams, if you double click on it, you can see an arrow has shown us that this is not supported. So you have not defined whether it is a cantilever or not. That is why you're having this warning. Okay, so what you just have to do is that you need to screw down, just have the beam, any of the beams selected. For instance, we have 2B5 first, select it right here, then come to the property window, and then you scroll down to where you found the released. Okay, here is the release. Expand this release, and then you will see, you can see over here we have cantilever end 2, all right, and then we have cantilever end 1. That's why I said when you are drawing it, you should know where you start and where you end. Where you start is your end 1, okay, and where you end is your end 2. All right, so we want to cantilever end 2 because that is where we end. All right, so select on this, meaning this has been cantilevered successfully. So now if you click on validate again, you can see B5 is gone because we have actually applied the cantilever successfully. Let's look at B6. 2B6, this is 2B6, select it, and then scroll down to the same provision where you have release. Where is the release? Okay, this is it. Expand it, then cantilever end 2, apply it successfully. Select the next one, so cantilever end 2 as well. Select this one, cantilever end 2, select this one, cantilever end 2, this, cantilever end 2. You see, so we have resolved this warning. Now how do you know that? You just have to click on the validate again from here. So once you click on validate, okay, we still have beam 10. All right, that one is not this 2, so you have to select it and then scroll down to the release provisions, cantilever end 2, release, cantilever end 2. All right, I think it is done. Click on validate. Good. And then we have the load. We have not loaded this, the load cases for the model. Everything is good. We just have a load issue, which we will load it later. All right, so that is how to correct cantilever and how to apply cantilever using Tekla Structural Designer. All right, so we proceed to model the reinforced concrete slab at the topmost level, which is ST2. Click right there to get to the plan view of that level, and then navigate to where you have your reinforced concrete slab. Is going to be slab on beam right here. I will choose this one. I will choose this one, slab on beam, or you can choose to use flat slab or through. Okay, flat slab, we don't require beam, but we use flat and beam right here. So you can create a new slab right here, and then for the slab thickness is automatic. We are feeding the depth right here is 180. All right, so for the concrete class, we change this to the concrete class we used. Okay, we scroll down. I think every other thing is leave it positive, so we use select bar to insert this. So just click in this provision to insert the slab right here. So for this site provision, what you do, uncheck these provisions and then pick the first point, second point, third point. At the last point, double click here to have the slab placed. Continue the same thing, first point, second point, third point, double click right here to have the slab placed successfully. At this point, if you are yet to like this video, if you are yet to subscribe, please like and subscribe now. Like and subscribe now, and then drop your comment based on what we are doing right here. If you have a question, drop it in the comment sections. Let us proceed. Pick the first point, pick the second point, third point, double click here to have it placed. Okay, pick the first point, second point, third point, double click to have it placed. First point, second point, third point, double click to have it placed. First point, second point, third point, double click to have it placed. First point, second point, third point, double click the fourth point to have the slab inserted just the same manner you placed your slab successfully. Now we go. Okay, so we click on the validate right here. All right, everything is also good. So go to the 3D. So this is what we get for now. You can see our model is now looking very nice. So why I actually added this 0.45 is just for walkway around the tank. Okay, so we have another tank in this provision. So let's navigate to the ST1, and then we will use the slab on beam as well, these options, and then let's create a new slab from here, and then we proceed, scroll down. Let's see the strength of the concrete. We use 2025 options, and then we scroll down everything. We go by default. All right, selecting this provision to have a place successfully. Get back to 3D escape, and then we see we have the slab. So we are going to be having 5,000 liters at this level. We are also going to be having 5,000 liters at the topmost level. Okay, so we'll be loading this provision. We'll also be loading this provision based on the tank pressure we have calculated. We calculated 43.213. You have to check your own and let me know in the comment section, please. Make sure you check these calculations. I'm calculating for the tank pressure on the tank stand. Okay, the water pressure on the tank stand, all right, is 10,000 liter water I'm considering, and I've done my rough calculations, and I got 43.213 kilopascal, all right, as the load that the tank stand we actually received from the tank and then the water. So for the sake of the weight of the tank, I have to make this to be 44. All right, so this is the weight of the water. All right, the safe weight of the safe weight of the water, and then plus the safe weight of the tank, I'll make it 44. All right, so since I said that this level will be carrying 5,000 liter and the topmost level will be carrying 5,000 liter, I have to divide this 44 by 2 to have 22 kilopascal right there, which I will apply 22 kilopascal at this level, apply 22 kilopascal at this level to use and design the reinforced concrete element successfully. I believe this is understood, but just check, use your own method of calculations and let me know in the description, in the comment section of this video. Let me know that this is what you calculated, this is what you came up with, and how do I calculate if you want to ask me more questions, if you really understand how I calculated it. But the diameter of the tank I used for these calculations is 1.7 meters diameter tank I used. All right, so put that into consideration while you are doing your check. All right, so I will minimize this. At this point, we want to load this structure, so I will save this model again, and then if I come to the loading tab right here, I click in this load cases, and then in the loading window, you see the Tekla Structural Designer actually have some loads here. I don't need service load. I just want to work with these two loads successfully, the live and the dead load successfully. So I'll click on the delete option. I'll just click on the delete option to get rid of that load. So for this load, you see pattern eccentricity moment for precast columns, I get rid of that. I don't have need for that. So these are the two loads I'm considering. These other two loads will actually be applied at default on the structure. I click on the OK option. So to apply the loads, which are the dead and the live load, I'll come to this provision, check the first load icon right here, click in these provisions and activate the dead load. Okay, so for the dead load now, water load in a tank is supposed to be a live load. All right, it's supposed to be a live load because the water at some times get out and then it's being filled up, you understand? So it comes and then it also goes out. All right, so it's supposed to be a live load, but for the sake of this design, I'm going to be applying this water load as a dead load on this particular structure, because in engineering most of the time we consider the worst condition. Okay, so I'll select that. I'll use the slab load options. I'll pick on that. So over here I'm having 22, right? So 22 for 5,000 liters on the topmost. So this is the direction, global Z directions, and then I'll just have to select on that to have it placed. I'll also have the same load applied right here successfully. You see. All right, so for the live load, this has to concern about human activity that will work on this tank stand successfully. Okay, so I can just set that to be 2 kilonewton per square meters or kilopascal. successfully. I picked right there and picked here to apply this successfully. So I've been able to apply both the dead load and the live flow successfully on this task standards. You can see from here. If you want to view the load value, right here, come to the scene content, and then you look down on these provisions to actually see where it will be rating load. So just click in this provision. So if that is not actually responding, just click in the space escape first. So once you escape, now come over here and then check for the load again. You can see it right here, click right here and click on the text right here, click on OK. So you can see I've applied 2 kilonewton right here for the imposed load, and then for the dead load I've applied 22 kilonewton successfully. All right, so this is properly loaded, as you can see. If you have your question, drop it in the comment sections. All right, so we proceed. We want to carry out the loading combinations. So come to the load cases, click on this load cases, switch over to the combinations right here. I want to generate combination through these provisions, click right here. So I will get rid of this, I'm going to consider the dual combinations because of the foundations. All right, so I will use the first table and then final scenario. Click on next. So over here, click on next. Over here, click on next. Then here I will consider the positive directions 1 and 2 in both of these table. Click on finished to have the load cases generated, load combinations generated successfully. Click on the OK options. I did not consider wheel load in this case because this is not too high, this is not too high structure. Okay, so having done my load combination, I click on the validate. Now you see there is no more warning here. Everything is cleared, everything is good. Okay, we are good now to carry out the analysis, okay, of this project. So I'm going to be running both the analysis and design at the same time. So come to the design tab right there, and then there are some things you need to check here. Things like the the reinforcement selections. This is where you actually see it. For the reinforcement selections, for the beams, the minimum is 12 and the maximum is 25. Okay, so if you want your minimum to be 16, this is where you make changes. All right, so for the columns it's the same thing. Column, the minimum is 16 right here. So it all depends on what you want. All right, so we go by the default, click on the OK options, and then we proceed. We use this tab of design or statics under analysis and design. This tab we analyze and design at the same time. So just click on it once. So once you click on it, you give it some time. So the program is going to carry out the analysis and design of all of the structural elements, as you can see. All right, we're having some warnings on these 4 members. Okay, so warning does not mean that the member failed. All right, warning does not mean that the member failed. The member has passed. Like if you check from here, due to the cantilever we applied. So if you come to you can design interactive design statics right here. So you see over here everything show good, meaning the member has passed, maybe due to the cantilever we applied there, making those members having some warnings. All right, or the structural directions. Okay, so all right, we proceed. Click on the OK options. All right, so now we have designed that successfully. Want to proceed to design the foundation of this structure, but let's check the structural element like the columns. Let's look at the sections and the reinforcement. Okay, let's check through the interactive design right here. Okay, so for the column you can see the principal bar size right here is 16, and then all the bars are 16 and everything is good with 16. Okay, and then sections is 225 by 225. So this section is enough to carry this task stand. All right, so you can be able to comment in the comment sections if there is anything you are actually observing from this design. Okay, so let me know in the comment sections if you have observed what you did not actually like, and then what you think we need to look at in this design. Drop it in the comment sections below. Okay, so this is okay, this is very okay, the section is okay, and then the reinforcement selections is 16. I think it's also okay. All right, and where is the U ratio? We need to look at the U ratio of this member successfully. I think the same thing is applicable to all of this. Then for the beam, let's select on this, right click, and then you click on the interactive design statics. Okay, so for the beams, the member selected is 12. All right, but I will use 16. I will use 16 for my beams. All right, but 12 is already enough. Okay, it's enough. And then the U ratio, let's see how to check the U ratio right there. If you put your pointer on this, you can see U ratio is 0.44. All right, and over here U ratio is 0.66. So the U ratio are okay with the steel area selected successfully. Okay, let's navigate to the foundations. So we see how we design the foundations. So we navigate to the ST base right here, and then at the ST base navigate to these foundation provisions and click on the part footing. Before then, validate this model. All right, then click on the part base, select it, and then we do a window over the green line intersection. Release your hand to have a default part base placed successfully. This is default, this is not designed. So now in the property windows, you scroll down and see how you can make changes for the depth and the dimensions. X and Y, do not make changes. Those are the default dimensions. After design, everything will change. Okay, so we need to make changes to the classes. Okay, for the class we use 2025, and then also check the bearing capacity. Here we used the bearing capacity is going to be 200 kilonewton per square meters, or 200 kilopascal right there. Okay, then for the soil surcharge provisions, so we can leave these provisions as none. For the surcharge depth, you can also leave that as none. But if that is provided in your soil report, you can add it up. Okay, so for the concrete cover, you see we have it to be 40, so we are good. All right, okay, after which we proceed, and then we click on this provision that says design part bases. All right, just click on that. So this part base will be designed successfully, and as you can see, the design is done. We are having 0.93, and then we have 1.25 meters as the dimension, and the depth is 300 millimeters right there. Get to 3D, and then you can see once you navigate from here, you come to where you have foundations right here started. Then you see that all of these members are sparse. You can also right click on it and check for the interactive design right from this window, this drop down window. You can check member, design member, generate drawing, generate report. All right, so all of these things is what you can do using this drop down provisions. All right, so these are the calculations. The program has checked for sliding, for uplift. It has also checked for shear capacity and punching as well. All right, so click on the close options. All right, we are good. We want to design the reinforced concrete slabs, because if we come over to the slab/mat design, if it's late in the statute, you can see not yet designed. All right, so for us to design it, we need to navigate to the design provisions, and then you see here we have design slab right here. Just click on it to have the slab design successfully, just like this, and then the reinforcement is being generated. So we have 12 as spacing 250 millimeters, and then direction 1 and the same thing direction 2, both top and bottom successfully is being generated. So we are done with this design, as you can see, very quick and very fast, and I hope you understand this process. Let me know in the comment section. Successfully click on validate to validate this model. All right, so now you can go back to the physical or the structural view. All right, so now you see this is what we get from here. Okay, now we will be proceeding to generate the drawings for the reinforced concrete columns, drawings for the slab, and as well as the beams, including foundation, successfully. Okay, so for us to do that, first of all, save this model, and then you navigate to this draw options. So click on this drawing management. So in this drawing management, just select the type of drawing in these provisions. We want to produce the reinforced concrete detailed drawings. Select right there and click on the add provisions, and then click in this content, and then these are all the columns. Okay, Some of the columns are grouped, some are not grouped. I want to advise bring all and produce all the drawings, okay, because not all the columns are similar. That is what they are saying. No, we did not check all the columns. Some of the columns, the reinforcement may be changed, but the section are the same, so they cannot be grouped as the same column. All right, so I've been put them in this panel. Click on the OK options and then come to these provisions where you have a view drawings. Click right there, and then over here you can work with the scale, and then you can also work with the text height. But for the sake of this size of columns and the height, we are working with the given scale as well as the given text height. Click on the OK options. So this will automatically open AutoCAD, and then it will now transfer all the drawings of the reinforced concrete columns into AutoCAD, well arranged. That is why Tekla Designer is very unique. You see the drawings are well arranged, well detailed, that you don't have any much work to do. I click on no option here, so you can see. So we have the one that is grouped, and then we have the one that is ungrouped. So this is the column, as you can see from here. This is the section of the columns, and then we have 4/16. Okay, we use H10 for the tie or the links, and then the spacing is 125. See how close the spacing is because of the load that is coming on this particular member successfully. And then you can see we have also the starter bar from the foundations. Okay, so this is the base level and this is the foundation level. There's a way to set this foundation level, okay, a provision to set this foundation level. All right, you can check or be able to join our members. All of that are in the membership video, so join our membership and you will get access to all those videos that explain much on Tekla Designer. All right, so these are columns, and you can see over here we have the grand total in kg. We have 324.21 kg of reinforcement. All right, and then the various sizes of the reinforcement are the H10 diameter and 16 diameter reinforcement successfully. All right, so from here let's proceed. We get back to Tekla Designer, and then we want to produce the beams drawing. So from here you can just select the beam detail, add it from here, and then click on the content, put everything to these provisions, both group and ungroup. Click on the OK options. For the beams, we go also by the default. Click on view drawings, and then here the settings here are fine. Click on OK to have it produced successfully, just like this in AutoCAD. So you can see how nice, this detail are. You can see that you wouldn't need to even adjust anything. There is nothing you can adjust. And then this, I've told you the level already. This is at 3000 millimeters. Okay, the level where this beam are is written right here boldly, 3000 millimeters. Okay, so over here we have 6000 millimeters. This is the level where this beam are. All right, so you can be able to see your beams and the levels where the beams are being created. You can see the cantilever with beams we designed, well detailed successfully. You can see right here. So with this, do you have anything to edit? No. That is why Tekla Designer is special. All right, it's special. So with this drawing, nothing to edit, just arrange your drawings and then be able to publish it successfully. Everything is very bold, visible successfully. All right, we navigate back to Tekla Designer. We want to be producing the foundations, so we use the isolated isolated foundations detail options. So we just have to select on that, and then click on add. From here, click on the content. We have 4 isolated parts. Okay, in this case Tekla Designer does not group, it doesn't group your foundations. All right, so it will give you the detailed drawings for this successfully. Let's click on the OK options and then come to view drawings, and then for the scale and the text height we go also by default, and then click on the OK options to have it create right here successfully. Okay, so you can see we have 4. I said it does not group, but you can see from here Tekla Designer have grouped this out of the 4 columns, out of the 4 foundations footings, because they are similar. All right, so it gives us just 1, and then let's see what it says. You can see over here 4. All right, so this represents 4, so you don't need to do any work right there. Tekla Designer have grouped this and give you just 1 and name it under here as 4, and the same thing is actually incorporated in the uh, in the bar weight calculations successfully. For the bar weight calculations, all the force are here. All right. So this is why Tekla Designer is very good. All right, so this is our foundation detail. We have created foundation detail. We have created our beam detail successfully. All right, see, we have created our reinforced concrete columns. So all of this, you don't even need to edit anything much, nothing to edit. Unlike some software, you need to, you know, you need to, waste that time, to edit, spend time to edit successfully. Okay, so here we go. We want to produce the slab reinforcement. Let's see how to produce a neat slab reinforcement. All right. Some person will be saying that why is Tekla Design does not detail slab. Let's see how to do that now. Okay, so over here now, for the slab, if you select in these provisions, and then you will see slab/mat layout. Select that and click on the add provisions, and then in this view content, just make sure we have two levels. Okay, we have level 1, we have level 2, we have the base. Just move all to these provisions. Move this as well successfully. Just click on the OK option. So now come to the view drawings. So in this view drawing provisions, you can see the scale that we have is scale 1:100, but the slab area we are considering are too small. So what do? Where we need to reduce the scale, we can use scale 1:25 from here. Okay, and then for the text height will be too big, so we can use text height, let's say 1. We can use text height 1.5 as text height. So when you have a smaller design or a smaller slab area to actually produce detail in Tekla Designer, this is what you do, so that you can be able to see a detail. Otherwise it will look very unkept, like everything will jam packed. All right. So we proceed. Let's click on the OK option and see what we get from here. All right, here we go. You can see, all right, this is the base level of it that shows you the reinforced concrete column points, and then this is the second level of it, and this is the slab detail. You can see now, you see the slab detail, this is the slab line, and this is the reinforcement right here. All right, spanning. And then in this direction we have the same thing right here, and this is slab thickness. So you can see that we have our detail reinforcement right here, and then over here we also have our detail reinforcement, and you are able to see this reinforcement and then the text successfully based on the setting we did. So okay, assuming we didn't do the setting, you won't be able to see anything at all. So some of this reinforcement we are pushed outside because the area of the slab here are too small. Okay, so from what you have here, you can just use it to edit your slab and make it more presentable, and then you put your drawings together and everything is good. You can proceed and publish your drawing successfully. Okay, if you are yet to like the video, hit on the like button. If you are yet to subscribe to our channel, subscribe to our channel and stay connected. And I'm inviting you to also join our channel membership. Click on the join button right there and join our channel membership, and you will actually enjoy the videos that we add in the membership tab right there. Okay, let's get back to Tekla Designer. At this point, we are done with all the drawings, and then click on the OK options. Here we go. If you want to produce a report, as I said earlier, you can select on the member, right click, and then you see options for report. I don't know. Okay, we have it here. See option for report for member, for this particular member. So you can produce through this provision. You can also come to the report tab right here, and then for the modeled report, all right, you can change this provision to building design options, and then you make it active right there. So after which what you have here, we have the steel, we have the concrete. We can move the steel out and then expand the concrete. So if you want to produce all the reports, you can just produce them. You can see the beams, you can see the columns, you can see the walls, and then you can move the walls out. The ones that you wish to produce, you can actually move out, and the one that you want, you can't allow it. You need the base, you don't need the pile. All right, so these are all the structural elements based on the type of structure we design. Okay, we have the beams, we have the columns design, we have the slab, and then we have the part base design successfully. Alright, so having selected all of that, click on the OK options. Let's see, click on the view report. Let's see if it can be able to show us that. Okay, so here we go. This is our report, and then you see those beams that we were having warning on it, they are also having some warning right here. But you can see the maximum utilization ratio is just 0.18, but it's having a warning, all right, which is very minimal. And then this one's designed at 0.6. So in this case, what you need to do, this one designed, you can also use the same property to design the one that has some warning. Okay, or the warning can also be corrected, but there's no time to do that. So if you scroll down, you can see the detailed calculations given right here for the beams. So if you scroll down, you see also the walls for the column. I think all is compiled in this provision successfully. All right, so over here you can see for the pad footings that was designed, and then which is the last thing. This is for the columns. All right, I think the slab is within. The slab is within, or if you did not see the slab, you can create that successfully separately. Okay, so now you see we have been able to carry out the modeling, analysis, and design of the reinforced concrete handstand successfully using Tekla Designer. Don't forget to like, do not forget to subscribe, stay connected. As we stop here, see you in the next presentation. And you can check the description of this video. There are some templates you may be able to use to fast track your drawing. There are also a group chat that you will join. Okay, WhatsApp group chat you can join in the description of this video. Bye for now.